Good evening, everybody. My viewers, all my students, Glorious, and the rest of the students. I believe you had a wonderful day. So for today's class, we will basically be looking at some principles that governs chemical change and physical changes. And as a matter of fact, we during the day we had a very wonderful class with the students, and also there were some jam questions which they were finding it difficult to give answers to. So at this point in time, that is why we promised them that we will go on air and we share the question with everybody for possible explanation, so that if you didn't get it when we were explaining in class, you can possibly take time now to follow up. I don't know if my students are with me. I don't know if my student is with me, because after that we will be talking about looking into organic synthesis, which is the basis for this class. That is for SS3. But I just want to use this few minutes to explain something for most of my students in SS1. So today in class we were explaining, we gave them a lot of questions on the first, I think the second topic for the term, which happens to be physical and chemical changes, a subtopic under standard separation techniques. And at the point, most of those questions were confusing, and my students said I should explain most of them for them to understand. Now, the first thing which you actually need to know is, anytime you are faced with a question, try as much as possible to look at to strike out confusing parameters. What are these confusing parameters? Parameters that you know that they don't even belong. There are options that you will notice in the question. You will notice most of the option does not even belong. You strike this one out. With that, you have limited yourself to few questions, few options. From there, you can now look at it in-depthly. You basically see the answer. Don't rush to answer. So first and foremost, I will, if you are my student and you are online, I can see 4 people are online now. If you are my student in SS1 and you are online, I just want to see you raise your hand, and so that I can know that those set of students are there with me. All the same, we will proceed. So we say that we were talking about chemical and physical change, and we said that physical change. Let me start with that one. Physical changes are changes which can easily be reversed. It can easily be reversed, and in which no new substances are formed. That is an example of physical change. Now, for JAM students, if you want to write JAM basically would not ask you what is physical change, whereas they will tell you which of the following best define chemical change or physical change, and they will begin to play their options. But for the very essence of this class, once you have been able to know that physical change, it is easily reversed. Let me remove the word reverse. You can take it back to what it was. For instance, if you have A typical example is your ice block. If you remove ice block or you put water in a cup and put it in a fridge, it will solidify, it will freeze and turn into a solid. At that point in time, there have been change in state from what liquid to solid with respect to changes in temperature, because the temperature at which you had the liquid water is different from when you put it inside the fridge, right? So at that point in time, as temperature varies, you notice that the water begins to behave based on what the environment which it is. So at that point in time, there have been a change of state from liquid to solid. For you to get back your water, you can remove that water from the fridge and keep it. Before you know, it will melt and turn into what? A liquid. So we can say freezing of a liquid, or we can say example of physical change is freezing of water or solidification of water when you put water in a fridge and it gets solidified. The next one is dissolution of common salt in water. When you are dissolving common salt in water, for instance, you are having salt, I'm going to show you having salt plus water. At this point, remember what I said in class, you will be having your solution. You have you have salt. I'm going to show you what I'm writing, plus water, okay, and you have your, that process is mixing, you are mixing it, and you have your salt solution, right? Salt solution. So if you have gotten salt solution, at that point in time, let me show you what I'm talking about. At that point in time that you are having this, look at it, everybody, look at it. At that point in time that you are having this, look at it, salt plus water, and you see the reaction is mixing, give you salt solution. This is a solvent. This is a solid. The salt is the solid, while water is a solvent. And when you mix it, you have salt solution. This is also an example of physical change. It is an example of physical change because no new substance is formed, and you can easily get back your salt and water by subjecting this salt solution to evaporation to dryness. So if you subject this particular system to evaporation to dryness, let's say you are now reacting, now you'll be having salt solution, and you will have, at this point you are applying heat to it, you have your salt plus water, right? You have your salt plus water. So at this point in time, when you have been able to get your salt and water, it means that you have been able to get back your salt, which was your solute, and your water. Now, heating is used because at this point, salt will not decompose. It will not decompose to another thing. Another typical example is the dissolution of sugar in water. If you dissolve sugar plus water, it will give you sugar solution, right? It will give you sugar solution. This is also mixing. You are mixing it, okay? It also gives you salt, sugar, and sugar solution. Look at it. This is what it's gonna give you. Now, if it is giving you this, so what if you want to get back your sugar? What process would it be? What process would it be? At this point in time, please don't make that mistake to say that it will be evaporation to dryness, because at this point, sugar will undergo decomposition if you heat it directly. So at this point in time, you will subject this man. If you want to get back, if you want to move this way to get back this, you will subject it to what? Crystallization, right? to crystallization. Remember, I said that in class. Then you will get back your sugar and water. This is a perfect way of obtaining salt. The process, the separation method that you can use to get back salt that decompose on heating is by method of crystallization, and sugar is one of them. Again, having said that, we have also stated that magnetization and demagnetization of iron rod is an example of physical change. So we also have, I think we listed so many examples of physical changes. Yeah, we mentioned so many examples. I believe my students that are there, if you are looking at your note, you can also recall most of them. But for chemical change, let me quickly go to chemical change so that I can analyze one of those questions that was giving you guys issue. So chemical changes, which we have stated clearly, are changes which is not easily reversed, but new substances will be formed. At the end of the day, new substances will be formed. A typical example of chemical change is when you dissolve calcium oxide in water. Calcium oxide in water. That process is called what? Slaking. Calcium oxide in water will give you calcium hydroxide. It will give you calcium hydroxide. And the process of dissolving the ore of group 2, the ore of calcium, process is called slaking. The process is called slaking. So if you dissolve this with water, you are going to get this particular product. That's a product you have. That's a product you have. I don't know if you are seeing it clearly. That's a product you have. Look at it. Remember, for my SS3 student, if you are there, recall that I said when the ore of group 1 and group 2 is dissolved in water, an alkalis is formed only. I don't know if Glorious is there. An alkalis is formed only. But when you are dissolving the metals itself in water, alkalis and hydrogen gas is liberated. And I remember stating clearly that that is one of the methods of preparing what? Hydrogen in the laboratory. So this particular reaction is called the process of slaking, where you quick calcium oxide, you can call it quicklime. This is also called quicklime, reacted with water to give you calcium hydroxide. In another vein, this is an example of chemical change. In another vein, you can have calcium reacting with water in the liquid state to give you the same calcium hydroxide and alkalis, calcium hydroxide and alkalis plus hydrogen gas. Please take note, at this point in time, hydrogen gas will be liberated. Look at that. When the metal of group 2 reacts with water, it gives you an alkalis plus hydrogen gas. We can comfortably say that this is one of the methods of preparing hydrogen in the lab. Right? Hello, Peter. I can see you. It's one of the methods of preparing hydrogen gas in the laboratory. So this is an example of chemical change. Dissolving. Now, don't let it be so cumbersome. What is one of the methods of preparing hydrogen gas in the lab? Reacting the metal, calcium plus water will give you calcium hydroxide plus hydrogen gas. That is one of the methods. And this is an example of chemical change. You can see new substance is formed, which is calcium hydroxide. It is not easily reversed. You cannot say that from calcium hydroxide plus water plus hydrogen that you can go back to calcium calcium plus water molecules. No, you cannot. It cannot move in that sequence. So at this point in time, this is an example of chemical change. Another typical example of chemical change is rusting of iron. Rusting of iron is another example of chemical change. We have so many of them that I listed there in class, but I can just mention a few for time's sake. Now, Most of those questions that my students got wrong were simply because they didn't actually, maybe most of them did not pay attention properly. That is why this class is necessary. These questions that has to do with the solid T, liquid T, and gaseous T, okay, and you were having something like this, the arrow and this. So if this was X, Y, Z, and they are asking you to explain the state, to which state is X, which state is Y, and which state is Z. So that question was very, very simple, and it takes you nothing to, it's just for you to look at it and look at it very carefully. But most of you did not get it correctly. That's why I want to explain it again. If a substance moves from solid to liquid, from solid to liquid, is moving from solid to liquid, what process is that? What process is that? I'm using a different example now so that you can use that and compare what you have in your note. That process is what? Melting. From liquid, from solid to liquid. That means X there is what? Melting. Have you seen that the arrow from solid is getting to liquid? Is melting. Solid to liquid is melting. Now if it's moving from liquid to gas, from liquid to gas, that is what? Evaporation. Evaporation. Okay. And if it is moving from gas to what? Solid. From gas to solid, that is what? Deposition. Deposition. And this deposition, remember I said that during Harmattan season, you come out early in the morning and you are noticing white dew settling on leaf. That is a sample of deposition. Now in class, what were you noticing? We were having a different thing. I'm going to show that. We want to move from liquid to solid, and we want to move from solid to gas, and we want to move from gas to liquid. In other words, I want to explain it using this particular system. If it is moving from liquid to solid, that process is what? Liquid to solid, that is what? From liquid to solid, that is what? Freezing. Right? Now, from solid to gas, that is what? Sublimation. Sublimation. Example of substances that undergo sublimation is camphor. Hello, do you remember camphor, my student? Do you remember camphor? That is from solid, from solid to gas is a sublimation. Yes, sublimation. Now, do you remember camphor, or you call it comfy? You put comfy in your clothes, your box, so that it can smell nice. Before you go there, you no longer see the comfy again. That is an example of substances that undergo what? Sublimation. Another example is iodine crystal also perform that same principle. Iodine crystal. Okay. Naphthalene is also an example of substance that's sublime. And also I have mentioned three now from gaseous to liquid. That is what? Anybody? That will be what? Melody, Amala, I've seen you wrote sublimation. That would be what? If you're having from gaseous T to liquid, that would be what? That would be what? What would be the answer? Hello? If you're having from gaseous to liquid, that is simply condensation. That is simply condensation, process of condensation. So with that, you are good to go. Another questions that my student didn't get it correctly is okay, divine, can you help us with one of those questions? Or basically what you will need to do is for the question that has to do with because most of the question you guys felt is which of the following is example of a mixture. And of course the difference between compound and a mixture is that compound are chemically bound, while mixture are not chemically bound. They're not chemically bound together. A mixture can be heterogeneous, homogeneous, or both, while compound can only be homogeneous. All right. Now, if you had option A was seawater, option B was filtered seawater, option C now is soft drink, and option D let's say option C is filtered seawater is what H2O. Let me say water. And okay, peace. You are welcome for joining the class. And they now say which of the following among this, which of the following is a mixture? Which of the following is homogeneous or is an homogeneous mixture? Now, if you look at seawater, filtered seawater, soft drink, and water. Filtered seawater, soft drink, and water are all homogeneous mixture. Why? Because filtered seawater is free of particles that you can see in your physical state. All right. Now, if you are looking at, say, which of the following is a mixture? Which of the following is a mixture? Now, if you look at all of those options, option A is a mixture, seawater. But this filtered seawater is not a mixture at that point, because you will not be having some particles in it. It must have been filtered off. At this point, we are not looking at the hardness of the water. That's not what we are talking about. We are now looking at identification of mixture based on physical properties. What you can see and what you can see is it homogeneous? Is it heterogeneous? Do you have Coriolis particle in it? And don't forget what we say is homogeneous substance. We say that homogeneous substances are substances that are what? Uniform. They are uniform. And I said an example: if you dissolved your milk and Milo in a hot tea and give you creamy color, that is, you can say it's homogeneous mixture. But if you put sand in water and dissolve it in a conical flask, you can say that it's a heterogeneous mixture, because two layers will be formed, and you can easily see the layers of salt or the layers of sand and that of water. So at that point in time, we confidently say that is what? A heterogeneous mixture. The particles, the particle of an heterogeneous mixture is not uniform. And most of those questions that you did not get it right were asking you which of the following is heterogeneous mixture, and most of you got it wrong. Another thing which I want to emphasize finally for my student, another thing that I want to emphasize for my students is for you to also be able to analyze questions based on what parameters that are confused parameter. Eliminate confused parameters that are confusing. You strike it out and you'll be left with few options. Now, for SS1 students, look at your notes very well this night. Please don't sleep. Maybe you can sleep by 10 o'clock. After 10 o'clock, you can sleep fine. After now, look at that, your note. Look at that question again. Is there any possible questions that you didn't understand? Can you mention the question? Maybe you can write it. Just write the question and maybe mention the option. I'll be able to put you through. But outside that, because next week I'm going to look at standard separation techniques, and standard separation techniques have a lot of questions on the JAM. Now, what we do for you to understand, at every subtopic we have questions, and we should be able to empty the question to you for you to be able to understand. Because if you don't understand those questions, we cannot go ahead with the next subtopic. Our kind of teaching is not just basically for us to teach and progress. We want to teach and carry every student along. We operate a system of no student is left behind. Okay. Okay, so that is just look at it and you wrote answer. And Melody, next time don't leave your note in school. I can see one of my friends said they left your note in school. Don't leave your note in school. If you must go home with any note, you should go home with chemistry, physics, mathematics, biology. If you want to be a science student, those major 5 subjects that you must have a distinctional credit. You must go home with it every day. Don't forget I say if you leave chemistry for one day, it will leave you for 1 month. Okay, so don't divine, don't leave your notes in school again next time. But you can also open any of the textbook and look at possible questions because your test is coming up next week. And those are the basic questions which I will ask. Okay, at this point in time I don't know. Okay, I can see divine is asking whether is A not a mixture. Is A not a mixture? A is made up of you have CO2, O2, and we have some rare gases in A. Okay, you have some rare gases in A. So A is a mixture. Some rare gases in A. Is there any other question? Another question from SS1? Okay, Treasure, you also left your note in school. Please, I want to beg you, don't leave your note in school again. Always go home with it. Are we having a glorious sister here? Has she been able to understood? Because she said she didn't understand the evaluation. I saw it. She didn't understand because of her scores. Okay. Do we have glorious sister here? I think I'm not seeing her. Is she among? Anyway, is there any SS3 student among her we can look at questions under organic? You can look at question under organic for them to understand. Okay. Number 12. What was question 12? What was question 12? Can I remember? What was question 12? One of my students says he has a problem with question 12. What was question 12? Okay, Glorious is here with you. Okay, that's good. What was question 12? What was question 12? I've forgotten. I'm not with my notes here. I'm at the office. You can see even at work, I'm trying to connect with my students. That is how to move along. What was question 12? What was question 12? Do you remember? Okay, Peter SS3. Okay. Is something related to bronze. Okay, it was the question was asking which of the following is a mixture now, and other options were there, but bronze, if you look at your notes, bronze is an alloy. Is an alloy. So if I may ask you, Melody or Divine, 2 elements made up bronze. What are the elements? 2 elements made up bronze. What are the elements? Well, I want you to open your notes, or you should find the answer. I said it. I gave you is in your notes. So it's a mixture. Anything that you can physically identify them are mixtures. So at this point in time, in the absence of any question, we can please do well to subscribe to the channel for easy understanding. Okay, for easy understanding. I don't know whether you have data. I would have just tried and see how I can switch to WhatsApp video call where I can connect everybody. But that one will not allow. Then you can share your screen. Then I'll also see what you are doing, and you also see me. But maybe next time I'll plan for that. So for SS3, we are digging deep into organic synthesis. And do not forget that we have talked about alkane. Okay, this one is better, no problem. Okay, If this one is better, no problem, I wouldn't go that way. So we want to look at this night to maybe explain a little thing about alkanes. And the first member of the alkane is I want to look at the methane gas. So we say methane here, of course, is slightly soluble in water, one of the properties. And do not forget one of the laboratory preparation of methane gas, that if you subject the reaction of what do we say about laboratory preparation of methane gas, what are the components, elements that you react to give you methane gas, which is collected over water, and what is the function of that empty conical flask in the diagram. I'm talking to SS3 now, but I want us to actually look at when you react, what do we react if we react subject sodium ethanoate, sodium ethanoate, and react with subject it to sodium ethanoate. Yes, that's true. React sodium ethanoate with soda lime. Sodium ethanoate with soda lime, that is sodium hydroxide. You will get your methane gas, and we say it is collected over water. It is collected over water. What is the reason why it is collected over water? It is slightly soluble in water. Don't forget, glorious. We say it is slightly soluble in water, but at that point in time, because it's slightly soluble in water, it is collected over water. Anything that is collected over water, what do you mean? What does that mean to you? If I'm saying a gas is collected over water, what does it mean? It means that the gas is less dense than water. That's what it means. That's why it's collected over water. If it is denser than water, it will be collected underwater. Okay? So you can now have your methane. And I also said that if you want to get your ethane, but we are picking the first member to represent every other member in the homologous series of alkanes. So if you react sodium propanoate with soda lime, it will give you ethane. Okay, it will give you ethane, right? But we're looking at the first sequence. That alone, you can begin to examine the diagram. Hello, my students. I don't want to know a chemical reaction, how I prepare, particular laboratory preparation, that I don't know how to draw the diagram. It is a no-no for me. So for me, you should be able to, once you notice that you are able to decipher the reaction, learn how to draw the diagram, because WAEC may ask you. Okay, so at that point in time, you can you add sodium propanoate with a soda lime, add sodium hydroxide, and you'll be able to get your ethane. So we later move to reaction involving chlorination of methane. Chlorination of methane takes place in a UV light. In the presence of UV light, the reaction will be regenerating until you get tetrachloromethane. Once you have been able to achieve tetrachloromethane, it's a the reaction is a chain reaction. It occurs, and again. Why? Because of chlorine is electronegative, and of course there is an acidic hydrogen that is there giving part for the reaction to take place. So you now see the reaction taking place until all the hydrogen atoms in the carbon atom is completely substituted with the chlorine molecules, and you have your tetrachloromethane. Learn the pathway of the reaction, you'll be good to go. Now, we later also explain things that has to do, we went into a double bonded compound, and this double bonded compound, we're looking at the alkenes. Do not forget that the general formula for alkane is what? C2H2N plus 2, right? For alkane is C2H2N. C2H2N. So you have this. So if you look at for ethene, when ethene reacts with the reaction for the preparation of how you can get ethene, laboratory preparation of ethene. Yes, Glorious, are you there? Glorious, are you there? If you are there, what did we say about the reaction involving ethene? How do we prepare ethene laboratory in the lab? And what was the function of the tetrazosulfate 6 acid that was used in that system? Yes, Glorious, I'm waiting. Are you there? Glorious, are you there? Peter from SS3, are you there? Michael, are you there? Glorious, you're not saying anything. What did we say is the reaction that involves how to prepare it in the lab? Okay, can you tell us? Divine Peter, Glorious. Okay, can you tell us now? Can you tell us now? Okay, what I mean is that for SS3, I have finished explaining for the alkane, and I took the first member of the alkane homologous series, the methane gas, how do you prepare it in the lab. So now I want to know, how do you prepare ethene? That is, I'm looking at the alkenes now. The first member is the ethene, that is C2H4. How do you prepare C2H4 in the lab? How do you prepare C2H4 in the lab? Please, if you are joining us now, do well to subscribe to the channel, comment, and also ask questions, share for other students for possible understanding. Heating what? Heating what? What do you heat? And in the presence of what? Because I know you heat it with something and it will give you something. It will give you something. Hello. It is prepared by heating. Heating what? Heating what? I want this class to be concentrated H2SO4. That is correct. So when you heat it with concentrated H2SO4, what do you have? I know you have something. What do you have? You will have what? Okay, Nkechi Okata. Nkechi Okata, if I should know, is this that my good student that normally trouble me with question? As asking what is the topic. Okay, actually we were done with a deep explanation for SS1, which we explain chemical and physical changes, which is a subtopic under standard separation techniques and mixtures. But for now, we're trying to explain something for the SS3 students. I don't know if we have SS2 students here also. Any SS2 student, can you indicate? So that I can also throw a point on what we did previously on periodic table for simplicity. So the topic is just organic synthesis. how organic chemistry 1, that is a topic which is for SS3, but anyone that is in SS1 can just be listening because their turn will come forward. SS2 you can still continue with us. So I want to know, you are reacting is prepared by heating what? With concentrated H2SO4. If you react an alcohol with H2SO4, you have ethyl tetrahydrosulfate 6, right? Ethyl tetrahydrosulfate 6. And if you subject it to tetrahydrosulfate 6 in the you have ethyl hydrogen tetraoxosulfate 6. Yes, in the presence of tetraoxosulfate 6. Yes, that is true. That is very correct. That means you are following. So what do you do next? There is one last thing you do that will take it to ethyl. You take it to ethyl. It will take it to ethyl. It will take it to ethyl. And I want to, that is, you are having, I'll show you the reaction. C2H5OH. The marker is not writing well. Plus H2SO4. That will give you it decomposes to what? That will give you C2H5 HSO4. That is ethyl hydrogen tetrahydrosulfate 6. That is what it's gonna give you, and afterward you'll be having I'm just very particular about this is what you'll be having. And now when you subject this to a more decomposition, you'll have your 18 gas. And of course it is collected over water. I hope you know it is also collected over water. Ethyl, ethane, and it's collected over water. Now for SS3, what have you learned? You have been able to know how to prepare the laboratory preparation of methane, which is the first member of the alkane family, of the alkane homologous series. Now we are entering ethene. The first member is, alkenes, the first member is 18, and you have been able to see how the reaction goes. Stick to it, don't allow it to leave you. Why you always acid? They normally acid. So now, what I want you now to look at, what are the uses of ethene? Remember we said one uses in polymerization reaction. In the polymerization reaction where you use to prepare polyethylene, and that process is called what? Polymerization. Remember? And I also said polymerization comes in two parts. We have addition polymerization and condensation polymerization. Addition polymerization and condensation polymerization. And I will mention what addition polymerization is and why condensation polymerization is. For condensation, little unit is removed from the reaction. Yes, it's used in making plastic. It is used in making plastic. Ethene is used in making a lot of things. I've seen my students have responded. So polymerization, we say that is a process. It is a process where small molecules, molecules called polymers, small monomers, monomeric units, small monomeric, two or more monomeric units come together to form a macromolecules. That is polymerization. And if you subject 18 to polymerization, you have polyethylene, which is used in this your nylon preparation, your nylon bath, and all those stuff. So furthermore, we also stated something previously before today's class. We made mention of stereoisomers, stereochemistry, where we explained the process that is involved And under stereochemistry, we talked about geometric isomers, optical isomers, optical isomerism. So the first one, geometric isomers, we said it comes in pairs and it takes place in double bonded compound. It comes in pairs. That is, we have the cis configuration, cis geometric isomers, and trans geometric isomers. Cis geometric isomers and trans geometric isomers. So if you are having a compound, let's say you are having this compound, this compound, 1, 2, 3, 4, this compound. This is example of a trans configuration. Look at it. The example of a trans configuration. I don't know whether you can see it. The marker is faint. I was very apologize for this. I will make it up to your next class. Look at it. Trans. This is trans configuration. So what is the IUPAC name for this compound? SS2. What is the SS2 and 3? What is the IUPAC name for this compound? I said it last class. Who can remember the IUPAC name for this compound? Don't forget, this is hydrogen. This is hydrogen. This is CH3. This is CH3, and there is a double bond. Trans but2-ene. Trans but2-ene. That is correct. That is correct. Thank you very much. Trans but2-ene is a geometric isomers. And if it was the cis, you'll be having hydrogen here and hydrogen here. So this one will come here, this one will go up, and that will be cis but2-ene. Suppose this is replaced with a chloro compound. If this was replaced, this H was replaced with Cl, this one was replaced with Cl, what would it be? Okay, I should spell what? Trans but2-ene. So let me spell that, my students. I should spell trans but2-ene. You have trans but2-ene, trans but2-ene. Okay, let me just quickly use this. You have, this is called trans but2-ene. That's it. That's how it is spelled, trans but2-ene for that particular one. And if, for instance, you are having and this hydrogen is up here and this one is down, this one is up here and this one is down, that would be what? Cis but2-ene. It's just for you to change this to cis but2-ene. So geometric isomers, I said, exist in two pairs, the trans configuration and what? The cis configuration. Please don't forget that. And we went further to explain optical isomerism. And we says that for optical isomerism, that it has the ability to rotate the plane of a plane polarized light. Ability to rotate the plane of a plane polarized light. And they are optically active. I want to also say that when you look at optical isomers, it simply shows compounds with the same molecular formulae but difference in the spatial arrangement of the atoms in space. The arrangement of the atom in space will be different. And as such, optical isomers cannot be superimposed. They are not superimposable. By superimpose, if you match it, it will not match. Okay, if you match it, it will not match with the original element. And of course, it doesn't have a mirror image. Mirror image. For SS3, you understand what I'm explaining? It doesn't have a mirror image. Treasure, yes, you say it to be trans, but two in. So, what can you say about optical isomers? Can anyone contribute what we said about optical isomers? I have 1 minute to go. Can we remember what we said about optical isomers? We said it can rotate a plane of a plane polarized light. And I talked about dextrorotatory and levorotatory. Which one is dextrorotatory? Which one is levorotatory? Yes, I'm listening. Which one? Dextrorotatory and levorotatory. I have 30 seconds. Time is going. Okay, for that is what I'm asking my SS3 students. Which one is dextrorotatory? Positive is D or positive? What does it mean by D or positive? Dextrorotatory, I will spell it dextrorotatory. If you buy your glucose, that is Nkechi, if you buy your glucose, dextrorotatory, dextro, and you have rotatory. That is, what does it mean? Where does it react? How does it rotate the plane of a plane polarized light? Is it to the right or to the left? Dextrorotatory is dextrorotatory and levorotatory are terminologies used to explain substances that rotate the plane of a plane polarized light either to the left or to the right. So which of them rotate the plane of a polarized light to the left and which of them rotate it to the right? If it is positive, it means it rotated to where? So when it is negative, that means it rotated to where? Dextro is the right. Dextro is the right. Rotate the plane of polarized light to the right. That is why your glucose, when you buy your glucose, you see D, glucose D. It means it's rotate the plane of a plane polarized light to the right. Levo is the left. It rotated to the left. So at this point in time, for SS3, is there any question you want me to physically look at immediately? Is there anything you were reading you want me to look at? I want you to come up with questions, IUPAC naming, because in your test you'll be having a lot of questions on IUPAC nomenclature. You're having a lot of questions in laboratory preparation for SS3. For SS2 periodic table, there are going to be a lot of questions. Then for SS1, you are going to have a lot of questions on chemical changes, physical changes, all those things that we have done. Limited question will come from introduction, that is introduction of chemistry, because you don't have much things there. But the other one, they will have a lot. You saw how many questions I gave you guys today, 12 questions. And I think one student had 9/12. All of them were jam questions, okay? One student had 9/12, some had 6/12, which I wasn't comfortable, while some were not able to get to average mark. That is the essence of those class. I wish all of them are here to see how most of you are responding to these questions. Is there any other thing that you want me to explain quickly? Is there another thing? I'll be doing this every tomorrow. I will come with my handout where I have a lot of questions and we will be writing the question and we'll be answering new questions so that you can also write new questions. So Treasure, is there another question? Is there another question, please? Treasure, Glorious, Nkechi, Okata. This Nkechi Okata, is it my student in SS1? Because I know Mrs. Okata is my boss, my vice principal. Is there another question? Okay. My student is asking about alkynes. So as for today, because once it is I have few minutes to log on to a particular class with my students that are my project student in the university. Most of them have called me that I should come online because alkynes, laboratory preparation and reaction of them. I will take that tomorrow with all of you, same time, 8 o'clock. And also I will start standard separation techniques for SS1. I'll start standard separation techniques for SS1. Very important. I'll start standard separation techniques for SS1. And when I finish that, I will mention something about the equilibrium of a chemical reaction. My students say they will not touch in SS2. I also talked about the equilibrium of a chemical reaction. Okay. Someone is asking, what is the general formula of alkanols? Who could help us with the general formula for alkanols? Glorious, what is the general formula for alkanols? Remember, is I will say that is C2H2N plus what? Plus what? Yes, that is for alcohol. He's not asking of the functional group. He's asking of the general formula. The general formula. C2. I mean CN H2N plus what? Is it plus 2 or is plus 1? OH. Is it plus 2 or is plus 1? Gloria is saying plus 2. Is it plus 2 or plus 1? I don't want you to confuse yourself. Is it plus 2 or plus 1? Because if you are having CN H2N plus 2. When N is 1, you're having C1 plus 2N, 2 times 1 plus 2. In other words, you're having CH, 2 times 1 is 2, plus 1 is 4. You are having H4 plus OH. So you had your OH. So what does that mean? Can you look at that? For instance, your methanol. Because methanol is supposed to be CH3OH. So it's going to be what? It's going to be plus 1. It's going to be plus 1. Yeah, it's plus 1. So if you are having C1 H2 times 1 plus 1 OH, that will give you C1 CH. 2 times 1 is 2 plus 1 is 3 OH. That gives you your methanol is the first member of the alcohol family. Your methanol, and the N keep on increasing if you have to again and again. Yeah, that is what is it. That is, I've seen it. That is methanol, and that is the general formula. Please, for clarity, so you will not get confused whether it is 1 or 2. If you are saying it is 2, write that formula. Now start N, where N equals to is strictly greater or equals to 1. Start with 1. When N is 1, put 1 in the equation and see what you have. If it does not give you what it's supposed to give, you know that you are wrong. So that is a perfect way that you can go about it, so you will not get confused. Okay. So at this point in time, I want to have class with one of my students in final year in the university. The person is even online, so that I can explain his projects for the person. So if you have learned something today, can you say hi? Amanda, my AKFUNQC, my students, all of you, I love you. Please do well to subscribe to the channel for more questions. Forget about the other part that you are seeing in the channel. Those one are updates that my family keep updating. But for this channel is purely based for students and for research purposes. Do not miss out for tomorrow's class. We are going to take live reactions, and I'm going to read out live questions, and I will dash some of my viewers recharge card. I'll buy somebody recharge card tomorrow. I'll buy recharge card. I have 1,500 to dash out to anybody who will answer the question. So get prepared. Is it gonna be that my smart student in SS1 that like asking me a lot of questions? Is it gonna be Glorious? Is it gonna be Peter? Is it gonna be Melody, Divine? All of you, Treasure? Is it gonna be you? Let's see who wins. So bye. Do take care of yourself. You enjoy the class. Thank you very much, Peter. Thank you. I really appreciate. And I also enjoy your contribution. Please do well to, if you are living closer to your student, most of you can log on together and sit together. At this point in time, I want to appreciate all of you for the opportunity that you have given us, and I want to thank your parents most importantly for subscribing data for you, because the country is not easy for you to come online for this class. I want to tell you that God bless you, and that you should read chemistry, read physics. And I will do something on Thursday, and what I will do is that I will be handling questions on physics for SS1, SS2, SS3, calculation questions for you to actually understand. I hope that will be welcome. I will dive into chemistry, physics, so that you can see possible solutions, those problems that have been bothering you, solve it for you. All right, Treasure. Oh, sorry, Treasure, you are just coming up now, and I think we are almost closing. Bye bye, Madam Okota and Kechi. Bye bye, Peter. Bye bye, Treasure. Bye bye. I love you all. Bye. Do take care of yourself. So I'll talk more about minor formulas. Which one is minor formulas? This Gloria should not stop bombarding me with questions. Which one is minor formula? Were you trying to say mirror? Okay, mirror formulas. Mirror formula. Oh my God, it's very simple. That is optics. Optics. That is optics. Mirror. That is optics, right? In physics. That is optics. That is where you have I think the formula is 1 over F equals to 1 over U plus 1 over V, right? Right? Yeah, that is a mirror equation. Honestly speaking, I'm gonna hit it in a way that you never expected, and you actually understand it very well. Mirror equation is always very simple, but the problem is that students don't understand when they say the object is behind the mirror. When you are using concave mirror, convex mirror, there are formulas for it. Okay, and I'm gonna explain it for you to understand. That will take place after tomorrow. That will not be tomorrow, okay? But I promise you, just for you, I will do that. That is optics. Yes, I know it's optics. Optics, okay? We are going to be looking at optics. Optics, okay? That is a question that has to do with glasses. It has to do with glasses, optics, triangular glass block, yeah, stuff like that. Okay. My student don't want me to go, so we can I can call any of these students that want me to call them on WhatsApp, can indicate, so that I can call them on WhatsApp and I can share my screen. Bye bye. I'll also talk about equilibrium.